Good morning, all. We can start shortly around 8 a.m. And I'll go through a short, friendly reminder today. All right, so get ready. I'll get some hot tea next to me and get ready for the class. So we'll start soon in 5 minutes, guys. Good morning again. Well, good morning, everyone. I think we will get start now. I mean, even though I think the rest of us gonna join us later on. I think right now I saw 11 people are, um, logged in and live or current view. Okay, so we're gonna start. But before I start, let me um, showing something, you know. So I think this is uh, the live view, or I captured 5 minutes ago. It's my wood ducks within in my wood ducks box, nesting box, that the mama just came in, and this is the yesterday image that I think we have probably eight or nine eggs already. So um, besides, stay at home, save life. I just spend some time, doing research on data side, as well as working outside for the various projects outside. I think one of which is my wood duck blind and wood ducks nesting box that I have two boxes. Each year we produce around 30 to 40 ducklings. Okay, it's something for me to enjoy the nature. But anyway, let's get start on our main things. Okay, every day before I start, I would have a friendly reminders, okay, for everyone. So the quiz last weekend, the day before yesterday, which is Monday morning, I saw around 20 each something, but then I think today I check it again. I think probably almost all 34, 33, 34 out of 35 has take the quiz. Okay, so make sure that you being on time, even though I'm a little kind of flexible, because I think I know right now is challenge time, and we are almost there. I think they'll start open up or unlock and let people reopening our nation again. Okay, so just hanging in there, and we are approaching toward the end of the quarter also. I think you are doing a good job. I think when we start this quarter, I'm a little concerned. I mean, with the first time online, like distance learning, online teaching, as well as online learning experience. But I guess it's not that bad. I think we're trying to make sure that you all follow, you all, have some. If you guys have any issue, let us know. Okay. So the second item that I want to touch upon is the term presentation. We're gonna start this Thursday. Okay. It's gonna be the Zoom session. It's gonna be the same Zoom link that I have used to do face-to-face consultation with you guys. Okay, so on the web page, okay, so let me go to our Moodle website. Okay, I have post the link or the page information. I think it's on May 5th. I don't know. I mean, today is May 5th, but always the current page is like one day behind whatever. I mean, on Moodle, one day behind the actual date. Okay. So on May 5th, we're going to have. I have post this information, okay, and there's a link there that you can click. But anyway, before the class, I will put whatever the link every time, so that you can click on the link and get on. I hope that everyone familiar how to use Zoom, okay. Otherwise, you just click on the link, okay, and then I'm the host to this Zoom session. I will put whatever the permission, so that you can share the screen. If you guys have not shared the screen, let me just quickly show you. Let me just sign in first. You don't have to sign. I mean, for you, you just click on the link. As the host, you have to sign in. So I sign in. Let me just quickly sign in, and then I'll show you. Okay. So let's say that I'll start the meeting. Okay. And in that case, I think you can use this share screen. Okay. In order to, during your turn of presentation, when you start speak, before you start speaking, you should share your screen. And the screen would be the file that you have upload, or I think I give instruction. We have some face-to-face meeting with some of our colleagues in the class, and that person asked me some convenience. So I told him that, the presentation score divided into two parts. Okay, the first part is your file that you submit, okay, which is 50%, and then your presentation will be another 50%. Even though you have upload the file, but then during your presentation you can replace with the new content or the new whatever the new diagram or the improved version. Okay, because as I told you, another 50% would be your presentation. So make sure that your presentation is effective, meaning that each slide you should not cut and paste has a lot of text or BC on your slide. Okay, change those into the highlight, the bullet list, because otherwise during presentation, if you make your screen too busy, it's going to be very distracting. Okay, so in that case you can use diagram, you can use animation, you can use whatever bullet list, so that the detail you can speak about, the detail of your presentation verbally. And then also, as I told you, we so far have 4 quizzes, so I expect to have at least 6 quizzes. Okay, there will be a quiz that based upon all you guys presentation. So that's why I think two birds in one shot. You're gonna learn something from whatever this presentation. Okay, as well as I gonna ask, some of those ideas in the quiz, so that for some of you guys may be a little behind. I think the quiz will be the tool for me to not enforce, pushing a little bit you to make sure that follow the class material. Okay, so I think I'm gonna end this Zoom session because we're not on Zoom. Okay, I just want to demonstrate. And here is, when you see this share screen, this green button here, I think during your turn of presentation, just click on that and then choose which window you want to share. Okay, so that is your presentation stuff. So let me go back to um, the friendly reminder or these things. So, and also I think we are approaching, this is the last main plan lecture or chapter, which is on file system or file implementation. Okay, as I mentioned, I think we talk about the processes, okay, in length. Okay, more than half of the quarters. And then last 2-3 weeks we touch upon memory management, and now we go into file management. Okay, I think the slide that I have uploaded is 72 pages. Okay, but I would cover around 50-ish pages, and then the rest of the time I will move on and then talk about the text shell. Okay, because I believe that some of you guys already have some good head start. Some of you guys who has not had class with me may need some help, so I'm gonna go to those the textual whatever overview that I have touched upon previously last time. I think maybe a month ago, but I think I will continue on, give you more idea about how to implement the pipe feature. Okay, if you guys have any question, please feel free to put in this live chat. I will continue glance through to see any question or not. So I think last time we covered a few of these slides. Okay, so I will go through quickly on file system implementation. Okay, these are the outline that we plan to cover, and these are the objectives that we have talked about. We want to look into how the file system being designed and implement, as well as directory. Okay, and then for the remote file system, such as network file system or NSF. Okay, there's material there. Okay, at the later part of this lecture. So I will encourage you to continue reading those details. Okay, I think I will stop once we're gonna go starting the network file system. Okay, because I also want to touch upon the textual aspect. I think last time, I think we end up this diagram showing you the whole. I think this diagram we have show you multiple times. Okay, we talk about process management, memory management, IPC in process communication. Now we're gonna switch over and talk about this file system. Okay, which the file system, when we talk about, in fact, in Linux type of environment, the file system is very powerful, quite flexible. It's not only support, regular storage in terms of create directory, store those file content, but also it will use to manage various devices. Okay, which, underneath it there's a device driver, which is part of the kernel or operating system, but it's more pertaining to a given device. So this is just like plug and play kind of thing. Modern operating system will design the system in a way that it will allow the new update to the kernel, because as you install the new device, you have to have a piece of the system program that communicate to those devices. And then when you write operating system, sometimes you need to anticipate that you will support the new device. And then having the new device, there's no way that you can pre-write, the system program for the device you have not created. So therefore, you create a framework in a way that you can drop in the new little piece of kernel update, okay, which is pertaining to this device, new device installation we call device driver. If you have installed a new whatever the device, I think right now it pretty much some of those devices based on a standard interface. But in the past, if you old enough, a lot of time when you install the new when you buy new peripheral, for example, the joystick or different things that you want to plug into your serial port or USB, and therefore it will require, or it will ask you whether you want to download that or install the device driver or not. Okay, so that is an idea of those device driver. But I think we're not going to talk about device driver, except I think if your presentation go quickly or go well, we have enough time, that would be my backup bonus material that I will cover. But in this chapter or lecture, I'm gonna talk general idea about file system or file subsystem. That in fact there's a mechanism, particularly on Linux system. Regular file system or file system design, it not only support regular file but also device driver. Okay, so let's move on. That's where we stopped last time. Okay, so now if we go and deep dive into file system structure. Okay, what is file? Okay, in fact, file is an abstraction that allow you to store, retrieve the related information into one bundle or multiple bundle. Okay, imagine that if you don't have file concept, how would you store your picture, your document, your PowerPoint, your MP3, your video file? Okay, so I mean, we take it for granted because I think file is given to you to the system, and now everyone knows that there's a file concept, which is a collection of related information. Okay, that would help or act as data storage. Okay, so in fact, you can think about, you have the disk, but this is give you a perhaps a big room that you want to start placing the item into the room, right? Now, I mean, once you start having so many items, you might want to create a folder, or we call directory, okay, where you will organize them into one location, so then it can be easily managed, access, and all those. So in terms of file structure, okay, and by the way, when we talk about file system, it's abstraction, but eventually it's gonna map into a physical hardware, which is your hardware in terms of store information. It could be, in the past, I don't think you old enough, or I'm not sure. You can just say yes or not. How many of you guys have seen a floppy drive? Maybe when you were born, because I believe that the first time I used the floppy drive is around 1980 something. okay. But then when we coming to 1990, the floppy drive is start fading away. The early floppy drive is like 8 inches, is as big as your dinner plate, okay. But then it start getting shrink and shrink, and now the floppy drive become USB, what were the thumb drive, or but also I think we also one time we have CD DVD drive. Now everything disappear, okay. So but then the file concept is still there. I think therefore, as I told you, the physical hardware, you can store your file in regular hard drive or SSD thumb drive, even the traditional DVD or CD, okay. But then as a user, we don't have to care about what is our physical hardware. All we care is file which we can open or we can create, open, read, and write, okay. So I think therefore I would say that file is one of the like best invention in terms of computing or computer or IT. Without file, I think our life gonna be much harder. Imagine that if you're gonna store your information onto the hard drive, and then you have to physically, store those bit and byte, onto which segment, what type of storage, what hardware. Here we don't care even on the even cloud storage. Nowadays we can use iCloud, G Drive, Dropbox. We don't even know, where is our physical file store at. It just gives us an abstraction that we can create file and then drop the file into that folder, and that folder will automatically sync up onto a cloud storage. Now take a look into more detail, because we're not going to be just user. I think the reason why we gone through operating system concept here, it will enable you to be a system creator, okay. In fact, we're not talking about how to program, how to build a system, but we talk about how the application user interact with the hardware, and hardware interact to each other. So when you start design big system, you have to understand the big picture as well as how those components interact, okay. So understand operating system with various aspects that would impact your application, your system that you're gonna design in the future, okay. So the file structure normally consists of two main parts, okay. The first part is a place where you store your data there. I think you have logical storage unit that operating system will map to the physical storage or physical hardware. And then the second part is a collection of related information or file header or file info, okay. I think we're gonna talk about FCB, which is file control block. The concept of file control block is like data structure, similar concept to a PCB. If you guys remember PCB that we talk during, the discussion of process management, okay. It's a data structure that you store information that related to thing that you want to manage. In this case, for file system, okay, then we have file control block or FCB. File system, normally, when we talk about file system, mainly the data aspect, as well as this collection of information, it will store in secondary storage, okay, which we call, can be your hard drive, SSD, or anything, but then normally when you have many files, when you create many files, then you should organize them into something that easily to manage in terms of the file system design or structure or organized, okay. Then it create a layer approach where each layer would has its own API or interface. As the user, if we are the end user, we're gonna sit on the top, which is user and application. So in that case, we'll use the file that we don't have to care physically how it gets stored. All we need to know is where is this file, in which directory, what is the file name, okay. And then we can create, open, read, write, and close. Okay, so we're gonna talk a little later on this layer of this file organization. Okay, and then I think the important part that I already touched upon with respect to file structure, we call FCB or file control block. Okay, which is a structure or storage structure that consists of information related to a file. Okay, we're gonna talk about this FCB in next two slides. Okay, and then I will demonstrate into Linux. Okay, and show information that you can retrieve from that FCB or FCB store those information. Now let's move on. This layer file system that I mentioned in the previous slides, okay, how the file system separate into different layers, okay. User sit on the top that at application program layers, okay, where the user or the program or it know is, where is this file located logically, okay, which directory, which file system, what is the name of this file, okay. And then they can open, read, and write or do whatever. Okay, and then that layer then map to the logical file system. That in fact, if the file associate with the storage, okay, which is your typical file, then it's gonna continue on and then consult or interface with file organization modules, okay, which is the right operation associated with that particular file, okay, of file type, and then continue on and start talking to your device to basic file system, I/O control, and device. If your logical file system or you open a file which is related to the device, meaning that sometime when you want to communicate to your mouse or any device, I mean, beside the regular file system, okay, your application, if you are a developer, you still have to open the device, the file, which is device driver, instead of those typical file. And then when you want to communicate to the device, you can just, if you want to send command to the device or read the information from the device, you can just use write to send the command, right? Or to send the data there. And then you can use read to read the result back to those devices. Okay, so therefore, it's very beautiful design in terms of the file system that create into this layer approach. All right, so I think this is just some basic idea how the file system get implement that separate into layer. Later on, I'm gonna show you different tools or aspect of each layers. Okay, I think at this point you're gonna see, or I think I want to see show you that the file system in fact is one bundle, but then when you start looking inside how things work together, it's separate into these layers. Okay, now I think we already touched upon the FCB or file control block, which is just like a file header. Okay, this is a data structure that store related information pertaining to a file. Okay, you have to think about given file. One file that you create, there would be two parts. One is file header or FCB, which is attribute to those files. Like for example, what is the file name that you create? Who created? Okay, file permission. Okay, the date, the timestamp on the file, whether when it's read, when it's create, when it's last access, when it's last update, and then perhaps if you are on the system that you can share the file among various users, then you would have the owner, the group, and then ACL stand for access control list. Okay, access, access, access control. C stand for control. Yeah, I wish I have a digital pen so it's easier to write by using mouse, and then L stand for list, okay, which is a mechanism that you can control access control list based on who you are, the role that you are act upon. Let's say that if you are student versus system admin versus professor, you can define those roles, okay? And then you can start grouping individual user into those roles. And then you can use role and access control list in order to control how the file get access, including directory. Besides, permission, the name of the file, the owner, the file size, and also there's a pointer or the information indicate that where is the physical file. The pointer to the actual storage, okay, or the mapping from logical file pointer to a physical file system, okay. So let me quickly show you demonstration how this FCB file control block being useful, or if you want to investigate a certain file system, okay. So let me go to let me show you some windows, okay. um, let me just try to get it larger here, okay. All right, so let's say that if I say ls-l, okay, now when you do ls-l, okay, you type an ls command, okay, but then ls is communicate to file system that list using system call to list the files, okay, based on the option that you provide. If I use dash L, okay, dash L would give me the full option, okay, the full almost, all file information that I want to see, okay. As I told you in terms of file control block, okay, ls-l retrieve the information pertaining to those files. You can do that ls-l token.c. If you want to see only regular one particular file, then you can provide option to dash L. But then if to ls, okay. But then if you just do ls-l by default, it's gonna list all the file in a current working directory in long format. But if I want to see only the file that token dash L. Now, as I told you, the FCB will give us the file permission. Here we have file permission like read, write, executable, read, write, executable, okay? But when I have blank out, that means I turn off the executable to that given file, okay? And as I think you know, or some of you guys who has taken 222 with me, I think I already gone through these 9 bits that represent file permission, okay? Which you have a group of 3 bits represent yourself, the owner of the file, and then when we say 3 bits, that means read, write, executable, okay. So in that case, we can use a binary number to represent for each group, okay. So for example, if I want to change the permission of this file, as we call tokens, right? Okay, so right now is read, write, read and write, and then no executable for myself, okay. And then you have read and then no write and executable to your group, and then you have only read and no executable, write and executable to anyone else, okay. So let's say that if I want to change the permission so that I will make myself to be read, write, executable, but I want to turn off all others. I want to turn off all the group that associate with this file has no permission at all, okay. So in that case, I can use command chmod. Remember 7? 7 mean 111, okay, which is 7, right? Because the first the binary number, the first the first field, which is 1, and then when you turn 1, that's 2, and then you have the third bit, okay, which is the second power up to, that is 4. So 4 to 1 is 7. That means 111. But then if this is binary number 411, will represent by 7. That means I want to turn the permission for myself, the first 3 bits, to be 111. Read, write, executable for myself. And then if I want to turn off, okay, the rest of the permission for group and other, I would put 0. That means 0, 0, 0, okay. So then I say token.c. Now I change the file permission, okay. to this token, okay, only for me to have all permission. Now you see that it has read, write, executable, and the rest gonna be blank out. All right, guys. So I think let me move on. And this is just some bonus idea that when we discuss about FCB or file control block. And besides, I mean, you have ownership because you see that who own it, and then the group that I belong to. In fact, if you want to list more group, you can type. I'll show you later on. But here it showed the first default group, which is staff, and then it showed the file size here, the time, that the last update time, and then here is the file name, okay. But also there are additional information such as the first information. There are a few um, character that represent the file type. If you see just dash, that means regular file. But then if this file is, for example, device driver file, okay. So I know that the device driver store in /dev, okay. Then you see that the first column represent like either C or B. C stand for character device, B stand for block device, okay. And then for character and block device, instead of file type, it has different other information related to that particular file type, okay. Because this is device driver, so you want to know what is the major number and minor number. I think last time or a few class ago, okay, I mentioned that the major number represent file type or the device type, and minor number represent the number of instances for that particular device. For example, the hard drive, you have the same type of the drive API, so you use the same device driver, which is the major number is 1 here, but then the minor number meaning that I can have up to 8 drive on my notebook here. All right, so now let's come back to the discussion of this file structure. Okay, so this is FCB or file control block, which is essentially a data structure that store related file information, but not actual data. Okay, the actual data would be point to this field, the data file block, or the pointer to the data file block. All right. So here, imagine that if you are user or application developer, as I mentioned, that file store in secondary storage, okay? So you can see that it quite far away from the user. So in that case, you're gonna have to bring the information from those files that store in secondary storage into the memory. And then in the memory, your application will make use of or interact or get the content of the file, okay? So once you start open the file, or your application open a file, okay, then in kernel memory, okay, for that given process, it will have or cache the directory structure that you try to access, okay. And then I mean, first read a file control block to see whether you have permission or not, okay. And once you open, okay, then normally if you have written program in C access file system, you're gonna use open, and then after open, normally it give you back a return value of file descriptor. You can think about as a pointer to those the storage or the file, okay. Because the file, where do you want to read? Would you want to start from the beginning of the file and then start moving along, based on whatever number of bytes that you read? So in that case, after you get file descriptor, okay, which is index that point to a file, then per process you have a file, open file table that track where have you read that file, and then that file may be perhaps shared among various users. So in that case, the system-wide open file table will be also maintained, because some of the file you want to lock the file so that other may not be able to read it, okay. Because sometimes when you want to update, you don't want anyone else to mess up with the file that you are dealing with or open. Imagine that you open a file and someone, if the system allows someone to access the file and then yank a few more bytes there, it's gonna mess up your file content. Okay, so therefore this system-wide open file table is a mechanism to track the usage of the file and then allow the user to reserve or lock the file, so that it allows that user to manage or operate those files. And then eventually those system-wide open, then it still console and then go read some of those data there. But imagine that now from here, when you read and then some of the file information stored in a process per process file open table, and then you have system wide open table. A lot of time there are some synchronization problem. So in that case, the file system ensure that it provide a mechanism to make sure the file system is still consistent. Because let's say that if during the time that you try to write something, but it has not, written those data all the way to the secondary storage, and then the system crash. So in that case, you have some inconsistent issue. Okay, so therefore later on we're gonna talk about a log structure that file system will keep log based upon activities on those right. If you are in the middle of writing something, but you have not complete that write statement yet, so this file system will keep the previous state until you have finished writing that file. Okay, it's just like if you are a database user, you can insert something into the table, but then that table has not been updated until you issue command commit. Okay, you guys familiar with those database things? So the same idea as in the file system. Okay, so I think later on we're gonna talk about why sometimes system has inconsistency issue file system, and how do we deal with or mitigate those issues. Are you guys with me? So I think here I'm just want to show you, now deep dive into how internally how it's work, things that from secondary storage is bring into the memory, kernel memory, and then all the way to user space. All right, okay, so I think all these interface in between, for example, from user space to kernel, when you open, remember what open is system call, right? So you perform system call, and then the operating system will act on behalf of you to perform that open. And then once open is complete, then it will return the result back and wake up the process, so that the process will get whatever the result or the return value and carry on. For example, in this open, if the user issue the program that perform open operation system call, then the user application process will get suspended until the return file descriptor come back. But then those suspension is just a millisecond. A lot of time, as the user, a regular user, you will not notice those overhead. It's just a brief. Sometimes we don't feel waiting at all. All right, so I think this is the idea of in-memory file system structure that shadow or has a fingerprint or footprint of the whole file system, because it, as you know that your memory is much smaller than your hard drive. Okay, so therefore it will deal with that given file. A lot of time your file may be 1 GB. You're not getting the whole thing in one shot. So a lot of time, it cache a portion of the file and then create whatever the shared copy in the kernel memory and eventually in user memory, so that you will represent those data into variable that you define. For example, variable could be an array of something that represent your image. Let's say that if you're going to read image file, in that case, it can read, those data that represent pixel and start create the copy or another representation of those data, okay, into different form. All right, so let's move on. This is important. This the idea of you see this separation, because of this would lead into inconsistency of the file system that one has to deal with or the system has to deal with. Okay, I already show you this diagram. The main point that I will show you again is this. Okay, important aspect of the file system, particularly on Linux, okay, it has the concept that adopt to or many other operating systems adopt the same concept we call virtual file system or VFS. Okay, VFS represent the name of virtual file system, which is a mechanism that provides object oriented way in order to manage the file. If you know object oriented, okay, concept or paradigm, you can create or instantiate various objects, and then after you instantiate that object, then you can apply the same operation to those objects if they are related to the same paradigm or the same concept. For example, when you do when you instantiate a string object, if you want to let's say add to string, you're not just add just like integer, right? Add to string is you let that object oriented or that all those object to perform adding by concatenate or add to string together by put the first string and then followed by the second string. But then if that object that you instantiate is integer, okay, when you add object, that means you do arithmetic operation by add a to b. Let's say 2 to 3, it becomes 5, okay. So the same idea into this file system. File system implement virtual file system. If you open regular file, then it will look up and consult with device driver and let onto the hardware control to open the regular file so that you can read or write or close or do something. But what if you want to open your device? Okay, let's say your joystick controller, okay, then it's gonna consult, because you will open, you use the same open, but then open different file type, okay. You open those joystick device driver, and then it will consult to, device driver, which of the open that implement that joystick, and then use the right implementation to control the hardware. As the user, we don't have to care which of those, open that we are using. All we let the operating system to take care of this. So if you are as the system developer, let's say particularly on those devices, okay, then you implement the set of open, read and write that support your device. And then once you install it, okay, the VFS or the virtual file system would be a mechanism to chill off the detail of this implementation to the user. All the user has to do just open the right file, and then the system will figure out mapping the right operation to those files that get open. If it's regular file, then you just open regular file, open, read and write. So then you can access local file system. But what if it's network file system? In fact, if you mount the storage remotely, okay, then there would be a piece of device driver that install on your kernel that once you open the remote file, it will go and fetch the data from the remote server or remote storage and bring it to the local system, cache it as if a local file system that the user doesn't have to know where is this file. Okay, so I think this is very powerful concept in operating system. I mean, specifically in file structure or file implementation. So let's talk more detail of VFS. Okay, VFS stands for virtual file system. Again, virtual file system is the key or the main idea or concept to file structure implementation or file structure design. VFS, as I told you, provide an object-oriented way of implementing file system. Okay, it's allowed the same API, which is system call interface, which is open or read, write and close. Normally, the typical operation of file system, there are four operations: open and then read, write, close. Okay, sometimes it's allow you to say open if the file does not exist. Okay, then you would open like create the file and then open the file so that you would have a file descriptor or index to the empty file, and then you can start writing something to a file. What if the file exists before? Okay, then when you open file, it may have an option that you can open existing file and then put the file index at the end of the file, so then you can start appending the new content or the data to a file. Or maybe there's some option that it would white out, the previous content, reset the whole thing, and then point the file descriptor or index to beginning of the file. So I think it's based on implementation or option, okay? But essentially, all this thing is done underneath virtual file system, okay? The API, I mean, to this VFS interface, it specify rather, to based on specific file type. As I told you, the file basic operation include open, close, read, and write. When you're ready to use it, then you will call open. After you open, you get an index coming back, or in Linux type of system call, you get file descriptor, okay? And then, after that, you can perform read or write. And once you no longer need it, then you close it. Why you need to do this? So that sometime when you open for write, you're locking the file. Okay, if you don't close it, then the file may be in stale state. Okay, so that you have to reset or doing something, otherwise that file cannot be used. Okay, so normally, once you terminate any application, if the application is open file, okay, by default, that process would maintain a file table that it's gonna go and close all those files. Okay, otherwise, if the file is left open, once other people try to access the open file, a lot of time by default behavior, the system would reject those operations. Okay. Uh, Now, I think this picture or schematic view that's showing you the beauty of the VFS interface. Okay, so you have file interface that underneath has VFS interface, and this VFS interface, it's map or provide an object-oriented way to access particular file system. Okay, so you may have file system one, file system two, because as you know, if you are Linux system admin, the file system on Linux, there are various file systems. If, in fact, in Windows, you have MS-DOS file system, you have NT file system, which is used to apply for enterprise grade, okay? And then Linux has whatever the ext2, ext3, various file system, but also this VFS can map to the remote file system, where the physical location is mounted or located in another system. Or the same VFS, okay, allow you to interface to different device, okay. So you use the same operation, read, open, read, and write, and close, okay. Um, so I think this is the main idea of virtual file system or VFS that provide object-oriented way to access various file system or device. I think again this picture is a classic picture that always shows. Okay, so in this case, as I mentioned, the device driver here, okay, is being used in order to interface to underlying hardware. Okay, so you have this hardware control. A lot of time when you, let's say that introduce the new system, okay, and the main reason that Linux or Unix type operating system is quite popular. If you look around, okay, beside Windows and iOS or Mac OS, you can see a lot of IoT or various device, okay, that has computer control. It's based on some sort of Linux kernel. Why? Because above this line, okay, if you want to port your system, okay, and then market your system, port meaning that develop a system and then sell your system as total solution. Above this line, there's no change. I mean, if you want to use a standard Linux, okay, the only thing that you have to replace is specific hardware control. Basically, some device driver and small shallow piece of a kernel to the hardware level that you need to support. because above here is would provide abstraction that you will manage the same type of process or similar concept to the process, similar concept to memory management, inter-process communication, as well as file system. Okay, now coming to on the left hand side, if you support whatever the device that you want to sell and attach to, let's say Linux, okay, all you need to do, you don't have to uh, ship the whole operating system. You can just ship the piece of device driver, okay, which particular to your device, okay, because no one else would know your device except you are the manufacturer of those device. So in that case, you have to map the API, in order to talk to your device. So in the case that you have to support open, close, read and write. And then if let's say that if my device do more than open, read and write, so why don't you do this? If you want to talk to using a specific command that does not support by read, write, open, maybe you can map some sort of the command and then send by using write read, okay, and read, then if you indicate to your device that this read, okay, or this write is not store some information, but the data that I'm sending is a command that I want to particular talking to those devices. Okay, so I think this is some idea. How do you develop, a computer control using the same concept? And in fact, in that case, you don't have to rewrite a whole lot of code. Only rewrite the part that your hardware support. Okay, now let's move on. I think I already show you this slide, so I think I would not showing you. This is when I do ls-l, and then you can see that the device driver, you're gonna see block character and then character device and block device. Most character device or block device, if I show you, character device is a low bandwidth, low speed of the device, such as mouse, keyboard, joystick. Those do not produce a lot of data there, mostly position or character. So in that case, you can use character device, okay, to control those. However, if you want to communicate to a device that generate or transfer big block of data, for example, the storage, the drive, the SSD, you're not writing character by character. So in that case, you're writing a block of the data in and out, okay? So in that case, a lot of time you have buffer cache in between. And besides, your hard drive or storage, you may have some high, whatever the bandwidth type of device, such as a graphic card. If you want to render the 3D card thing, then you have to have a stream of data in and out. So in that case, when we talk about stream of data, in fact, the stream, it comes with an array of block of data that come in consecutive way. Okay, so let's move on. I think we'll talk more about the storage or file system. Okay. I think this is quickly showing you, in fact, if I have time to cover the bonus material on device driver, okay, this is how VFS work with the device driver interface, okay. So you have your user program here, and then you have system call called open, read, write, and close here. But read, write, and close will consult with VFS, okay, file system switch that know which read, okay, because you open the file xxx and it know that xxx is based on xxx type, okay, the device xxx. So in that case, the virtual file system will map the write open, xxx open, xxx read, xxx write, xxx close, okay. So in fact, if you recall when I talk about when I do ls-l/def like this one, okay, you see this major number and minor number, okay. So during you install the device driver, okay, then you will communicate to virtual file system to say, hey, am I device type 1, okay, and here is a set of my operation that associate with this device one. So you register to the OS during installation of device driver, so that during the real operation or regular operation. When the user want to access to those device or that file system, then it will specify whatever the file name that associate with the file type, and then VFS will map and fetch the right operation of those device driver routine associated with that open, read, write, and then close. Okay, so this is a concept that I think is not that difficult to follow. Okay, and how VFS work with system call in order to map to the right set of device driver files. Okay, and I think this is just another representation that on VFS will consult with Linux kernel and then map those open, read, and write to the right operation. All right, guys. So this is major number. Remember, I talk about major number. Now let's talk about directory concept. Okay, and then we're gonna take 3 to 5 minute break. Okay, once you have so many files, okay, that you create, okay, then let's say that if you have 5 to 10 files, probably it's not difficult to search or look for those files. But then let's say that if you keep pile up and then one location you have 100 or 1,000 or 10,000 of those files. Okay, now it start become more headache to search for those files, and also it's inefficient because you can have to search one by one, and in case you say, oh, I have tools, but then your tool had to go through like 100,000 files there. So therefore later on the concept, when I say later on, probably 40-50 years ago, okay, because file concept has been introduced at least maybe older than me. I mean, when the first computer get introduced, in fact, the directory of hierarchical file design is called, the first one called ERMA, or Electronic Recording Machine Accounting, okay, published or introduced by Xerox, okay, which is those copy machine company. As I think I told you before, graphic user interface, TCP/IP, also invented by Xerox lab, or called Xerox PARC. Okay, so now let's go back and touch upon concept of directory structure or directory. Directory is a file system cataloging structure which grouping the related file into one location, so that you can organize them into multiple folder, and then within folder or directory you can have also subdirectory within those, so it allow us to easily access and manage. Okay, another concept you can call the cabinet or folder. Okay, now quickly touch upon the idea of directory implementation. Basically, the easiest way to do is using linear list. Okay, linear list or linked list, that is simple structure, okay, that you can string multiple file together by you have one file. You don't have to have, I mean, the whole file. In fact, you can use FCB, one of the field maybe point to the next one. Okay, so instead of, so introduces a field which is pointer to the next slide. So in that case, you can start create a linear list or linked list. But the linear list or linked list, once you have a lot of files, okay, then it's consumed. It takes time to search for the file because you have to go through each link, okay, each node, I mean, throughout the link. So therefore, once system start getting larger and larger, the evolution of directory, move toward hash table. You guys know that hash table giving hash, you have hash function that giving the seed or the name, okay, as a parameter to hash function. Then it would point to a bucket or an array of linked lists. So in that case, you are breaking up, the whole linear list into multiple linked lists, okay? And then based upon whatever this hash function, or in order to spread out whatever those names, so that the link would have an equal size. The best hash function would be, the distribution of those hash index should be evenly. Otherwise, if you have bad hash function, your hash table gonna become just like linear list, which is very long. Okay, and then and sometimes you may have the same name that point to the same bucket. Then just use the linked list in order to mitigate two files that the same name. All right, so this is the main idea, and I think this is showing you a sample of the left hand side is using uh, the the linked list or the linear the fixed size of the list, and then on the right hand side, it used it's on Unix or Linux that used inode representation, which similar to those hash function. Okay, and then this is more another more example, more complicated, how hash table is being used, and then point to this linear list. Okay, and then each would have some hash key value to compare and distinguish between various files. Okay. So why don't we do this? I think right now is 8 o'clock, 9 o'clock, guys. So let's pause for 2 or 3 minute break. Okay, 3 to 4 minute break. Go to the bathroom, get sip of tea, and then we'll be right back. All right, guys. So let me switch to if you guys have any question, feel free to type those questions. Okay, we will continue on. Next, I believe that we're gonna start discuss or going to toward file allocation, which is three types, and then continue on into log file system, and then hopefully we have some time that we can cover the text shell. Okay, all right, guys, we'll be right back. All right, guys. So now let me go back and resume the discussion. I think I already showed you this layer file system in early class, okay, that we have application program layer that the user doesn't have to know underline how the file gets stored and those mapping, okay. And then, you start having underneath, which is the logical file system, which is file subsystem that map to file organization module. So your VFS is somewhere here, okay? And then, in the file organization, once you have many files, then you have directory structure or directory that grouping many files all together. And then after that, it's if the user access certain file or file type, then it's gonna access the particular implementation of those device, okay, that store the file on the device that you want to communicate. So in that case, the basic file system will manage the allocation and control, which eventually will talk to the device, okay. So now I think coming along, we're going to talk about another important aspect, which is how those storage get mapped into your physical storage, okay. Okay, so assuming that we talk about, the regular file, I think it's not like various device that I mentioned to you. Now, in terms of the file that you want to store the data, whether it's a image or video or whatnot, okay. As I think we discussed in memory management, you have logical address versus physical address. The same idea in this file management. When you open or when you read and write, then you have to have physical storage, okay. And then the storage normally managed by as a block, okay. So now we're gonna discuss three techniques in terms of the data allocation method, okay. The first uh, method called contiguous allocation, okay, which is very simple techniques, but then there's some drawback there, which we'll discuss more detail. And then the second approach is called link, which is a block or the chain of linked list or the block link. And then last but not least is index allocation, okay. So the concept, the idea, I think is well connected to some data structure that you study in the past, like contiguous. There's no data structure. It's starting block and end block. And then it allocate a contiguous or consecutive block all together and associate with a given file. The link allocation is you can have the storage of given file scattered all over whatever your disk storage, okay. Doesn't have to be consecutive, but then the mechanism to string them together is a link or a linked list, okay, that from one block to another block to another block. And last but not least, you have table, okay, that gather all this file storage, okay, and then you use index from that table point to different locations. So let's take a look at this is three techniques that in overview that I mentioned. The contiguous, where you have this contiguous block, okay, for given file, okay. Here is one block. One block may not necessarily small. It could be a very large block, okay. It could be 16K or larger or smaller, okay. And then here is the link, where the starting, you have a starting block, and then each block you have pointer to the next one, and then the next all the way to the last one, which has normally a special indicator to say this is end of the block, okay. Or maybe sometimes you may have pointer to the end of the block, so then when you search for that given file, you can go from the back or you can go from the front. And then last but not least, you have one block that maintain the whole index that point to the actual data block, okay. So let's take a look at one by one, pros and cons. As I mentioned, okay, contiguous allocation, each file occupy a set of contiguous block on the disk, okay. And it's simple by giving the starting location and then the offset or the displacement, the length of the block where particular location that you want to locate. Okay, so in this case, when you have this contiguous allocation, you can access your file in random manner, because all you need to do what is starting block, and then what is the offset that you want to go to the next one. Okay, the only issue is similar to contiguous allocation in memory. You may have a wasteful space, because sometimes when you allocate contiguous, and then when you no longer use it, you delete it. Okay, and then so that you may have many holes there. So therefore, you have to perform some compaction. One of the issue is that once you allocate, what if you already allocate another file next to it? So therefore, your file cannot grow. Okay, there are an alternative way using contiguous allocation. Okay, we call extended file system. It uses multiple contiguous together, where the last block of the first contiguous block is point to the next contiguous block. Okay, but I think this is a characteristic of contiguous allocation. It provides random access. It's simple, but it may lead to wasteful space, and file cannot grow. Okay, so don't worry about this. This is just like representation of a file array, 512K block, and starting address, the starting block of Q, and then if you want to locate, then it plus Q plus starting address, where you're mapping to the physical location. Okay, and then the displacement is the R. Okay, which is from that address and how far along that you want to go to particular location. Okay, and this picture is showing the representation, or how the contiguous file allocation, where for example file count starting from 0. Okay, and then it has two blocks, so 0 and 1 here, and then file tr it start from block 14, and then it had three blocks consecutively, 14, 15, 16, and then etc. Okay, as you see that, once you start create, then you may have a free block scattered all around. But what if you have new coming file that you want to create and larger than available contiguous block? Then you run into issue, and therefore you need to start do compacting by shifting or moving file around. Okay, so the solution to this Veritas file system is use extend-based file system, where you can have a multiple contiguous block all together. Okay, so that's an idea of how to solve or simple solve contiguous allocation by having multiple contiguous multiple contiguous block or smaller block, where the last address of the previous block will point to the next contiguous block. The next one is link allocation. Okay, where you have one field in the block would point to the next block. Okay, so that it will form a linked list of a blockchains. Okay, I think the characteristic of link allocation is still simple. All you need to know is just starting address, and then you have no waste space or free space management. It's quite good, because the location of your data can be anywhere. As long as you still have block available, then you can just update the pointer to the last block to the new block that you want to locate. So therefore, um, the free space management is quite good. However, the drawback is there's no random access. If you want to access particular location of your file, you have to follow the chain. Okay, in order to go to the right location. In this case, the system that implement link allocation is the early Windows or MS-DOS and OS2. I think OS2 used to belong to IBM, now it disappeared, but MS-DOS also part of Windows system. Okay, so early Windows using this link allocation. And the concept of link allocation is that you just know the starting block, and then which is block 9 point to block 16, 16 at the end point to block 1, and then point to block 2, and then the last block is block 25, which is -1. Okay, so Now, I think this is showing the implementation of this the link allocation, okay, where this giving you more complete picture, okay, which is you have file control block here or file header, okay. Sometimes you call file attribute, okay, which you have name, you have permission and everything, and then one of the field would point to the starting block, and then will let you know the block itself, point to the next one. What if you have, for example, the problem with your hard drive, okay, let's say that the block that used to be part of the whole chain kind of disappear or has some issue that you can not read, okay, and therefore then the file recovery, it may not be easy, because in that case you're losing the whole thing, meaning that after you go to that, and then the rest of the file you cannot no longer to continue on, okay, because of what if this block is bad, okay, then it would not have information point to the next block, okay. So I think this one is also another potential issue in terms of file recovery. It's a little bit harder in terms of contiguous location. You can keep scanning and assuming that they are contiguous all the way until you find the next, maybe the starting of the next file. And in that case, you still have the whole thing, except you have to figure out where is the end. So that easier to do a file recovery, okay. Now, last but not least is the index allocation, okay, where you have one block as a file table, okay, just like whatever that page table. This block is act as index table that each of entry would point to the data block that belong to a given file. So each file would have its own one simple implementation. Each file would have its own file index table that it knows, how many block and which block that belong to the same files. Okay, so the idea is just like an array of the block storage. Okay, so I think this picture is showing in terms of file representation, you have file name Jeep, and then the index block is 19, where this 19, if you blow up, then it has a list or an array of the index block that, for example, the first block is 9, 16, 1, 12, 25, and where it used -1 to indicate that that entry is still free. So then therefore you can extend and add more storage there. So in this case, the file you can grow, easily. So in this case, the index allocation, it required it can be a drawback. It requires one block as an index table, but then it provides a random access. So this one address issue from that we discussed in link allocation. In link allocation, because of its form the link. So therefore, when you want to search for a particular file, you have to search in linear fashion. So in that case, you have no random access. The file free space storage or free space management is quite good, because it provides a dynamic access without external fragmentation. Only overhead, as I told you, is an index block. Okay, so let me show this picture. When you create index, okay, allocation, it doesn't have to be one level. In this case, you can have multiple level of index, just like a multi-dimensional array. The benefit of this hierarchical index allocation is that instead of, you have very long index table. In that case, you can break up into multiple multi-dimension that, one index can point to another index table. In fact, that index table would allocate an equal size, so that you can start allocate a collection of blocks, so then you can add up into a files. Okay, so most modern operating systems use this index allocation, including Linux file system that use inode structure. Okay, so in summary, okay, with respect to memory management, you have contiguous allocation, okay, which is simple, provide random access, but then it impose wasteful space as well as file cannot grow. This drawback can be addressed by Veritas file system we call extent-based file system. And then we discussed link allocation that it also quite simple. The space management is quite well because you can allocate file anywhere you wish as long as you have free block. Okay. However, in terms of contiguous allocation, even though you have some free block, but then if it's not large enough for the requirement for the given file, you cannot allocate. You have to compact. So therefore, it creates external fragmentation. So link allocation, only downside is no random access. Last but not least, you have index allocation that provide random access. Okay, free space management is quite well known. External fragmentation, only overhead is from the index table or the block that have index table reside on it. Okay, now quickly show those are concepts that a lot of modern operating system, okay, adopt using those concepts to create the file system, okay, or particularly the storage of file system, okay. Now if we deep dive and look into the Linux file system that using the structure called inode, okay, which is the concept of inode represent the last allocation idea in terms of index allocation, but instead of one level of index, it has multiple hierarchical index. Here we also show file attribute or FCB that consists of file name, the mode, meaning that permission, like change mode. You got remember the command change mode. I think it's derived from mode, which is permission, read, write, executable, owner, timestamp, date, create, update, last access, size block, count how many, and then you have direct block, which is essentially this block store the actual data. Okay. So in this case, you have direct blocks for frequent access data, but then if you want to grow more, then it will expand into a single indirect where you have one level of indirect block or index block, okay. And then if you have not enough space, you can expand to triple index or double index or triple index, okay. So essentially it's very flexible file system, and then it also can be efficient instead of, if you want to store something to be fast access, then those storage would be in direct block access, okay. But then when the file start going larger and larger, then it's gonna go to a single or double index. So in that case, it's gonna take a little more time. So I think there are some trade-off, okay. You want to store larger, very large files, then it's gonna slow the access there, okay. But then when we say slow with the modern technology, the drive, the cache, the idea of those things, bring the speed kind of, for human observation, okay. As long as you engineer the right number, you will not get annoyed on the slowness, okay. I think before I end, I think I have a few more slides that I want to complete this lecture, and then hopefully we have enough time to discuss the tech shield, okay. Otherwise, I may just allocate an extra time and discuss the tech shield in separate session. So we'll see. Now, as I told you, you have this block allocation. So I think you have to have a way to manage. We call free space management. Which block has been used, which block has been are still free or being allocated. So in that case, we have bit vector that represent the whole entire disk map, okay. And in this case, let's say that if we have this which particular size, okay, let's say 1 terabyte or 500 gigabyte, and then we have to know what is our block size, okay, so that we have the total size of the storage divided by block size, then we can have that many bit vector items there. So in that case, n is equal to the total size of whatever that file system or the storage divided by the block size, and therefore you're gonna have to have n block. So then you can have keep track 0 or 1, where 0 indicate is free and 1 indicate is occupied. You also can use this together with other mechanism in terms of make sure the data file consistency or directory consistencies. Okay. Now I think this is just a quick calculation how to figure out how many items in that big vector of free space management. As I told you, so the total size of the disk divided by the block size, therefore you're gonna get these many bits, okay, in order to represent. Now you can use grouping, counting, create linked list and all those. Then it will consult and update this bitmap vector in order to provide secure, reliable, and efficient way to do a file management. Particularly free space management. So I think this is some more detail that we already discussed verbally. Last time. I think this show linked list allocation. Now, and when we, I think these are a few more topic before I wrap up this lecture. Okay, when we discuss about efficiency and performance, because as you know that the disk space or the storage space, when you compare to CPU versus memory, CPU or register is much faster than memory, and your memory access much faster than the secondary storage. So imagine that the full, round trip, whatever life cycle of data application, you're gonna have to bring the data from the disk or the storage into memory, and then from memory to CPU, so that you can start execute those instructions. Okay, so therefore, in order to make, to reduce the bottleneck between various components that communicate. Okay, there are some techniques such as cache, or register, or something that will improve the performance. One of the main aspect to improve the file system performance using disk cache, okay, where you use main memory to cache the storage from your drive or secondary storage, so then you can bring ahead a lot more than your application need. Let's say if you need to read for example, 20 bytes of this bit, so that you can start arranging something. But then one block is maybe perhaps, the transfer rate is like block by block. So why would you bring only 10 bits? Okay, why don't you bring the whole block and then cache? Because you anticipate that your program or application may read the next bits or the next chunk of data. So the disk cache is quite useful in order to improve the performance. Okay, and then in terms of cache, you have free behind and then read ahead. Okay, technique to optimize sequential access. Read ahead meaning that once you read, if you read certain block, okay, or certain byte, okay, then maybe you go ahead and read more. Okay, in order to optimize the minimum requirement in terms of data transfer, because sometimes if you need 32 bytes, okay, but then the transfer, you have transfer of chunk of 16K. So in that case, maybe just bring the whole 16K. But then if you bring a whole lot more, then you're gonna have to make sure that you have enough memory or cache in order to store those. And then when we say free behind, meaning that if some of those data is being used, but it may be reused again. So in the case that you you free up and then flush the cache, okay, so that you can free up the memory and then you can bring more item. Maybe the anticipation of you may do repetition or multiple times. So in that case, you may use the technique called free behind and read ahead. Okay, some of the disk cache, it may be some similar manner to improve performance by create virtual disk or RAM disk, okay, which is slightly different, but essentially just use memory. So I think we're gonna talk about the page cache is the classic attempt in terms of improving the speed of a file system access. The page cache represent a page, okay, caching the page rather than the disk block using virtual memory techniques, okay. And in this case, you have memory I/O act as the page cache, okay, which is the memory map I/O is a hardware assist so that it allows the map of PCI address at PCI bus architecture, that control this I/O between North Bridge and South Bridge, okay, in order to map the memory map I/O so that you can cache some page in order to transfer between storage, secondary storage, and the main memory in order to support virtual memory, okay. But later on, this memory map and page cache kind of merge together. It's called unified page cache, which I'm gonna show you in the next slide, two slides, okay. So the first slide showing how the file system get read in, and then you have this buffer cache that in order to mitigate the slowness of underlying hardware, okay, with respect to file system. Then you have buffer cache, which is part of the memory that you can allocate to buffer cache. And in the past, some of the buffer cache also interact with the page cache, where the memory, virtual memory, that manage. I think if you guys remember, demand paging or paging, some page being used, then it's going to be in main memory, and some page is not being used at that moment. It may be written into file system. So in that case, the page cache represent those pages that we are caching, okay, with respect to a virtual memory, okay, that will communicate to buffer cache and eventually write to a file system. And then in terms of regular I/O, then you have buffer cache, to support in terms of communicating to those devices, okay. Sometimes those devices may be transmit the whole chunk of data, for example, your graphic card, okay. But then the graphic card in the past, um, it has different paradigm. Instead of paging, it transfer the streaming kind of fashion, right? But then you can map the streaming and the paging. Multiple page can represent a stream of something, and then you can track by the time scale how to move in and out those various page. When you when you control and manage two different device from storage versus regular device, okay. So therefore this picture, instead of you have separate page cache and buffer cache, then it become an idea called unified buffer cache, where you map the memory map page and then the original file system that you have buffer cache into one unified buffer cache, okay, so that the system can be more effective and more efficient in terms of bring in and out data from faster device, for example, CPU to memory, and then to eventually file system. So therefore, from previous issue or previous diagram, you see a separation between page cache and buffer cache and become unified buffer cache, okay, which it also support both memory map I/O and I/O mapping, or other I/O mapping from read and write, okay. So I think, and then you can see the actual implementation. If you guys are the GPU type of if you have a warrior machine that you install your GPU, this compute device is your GPU here. It could be NVIDIA or AMD, okay. And then you have device memory, and then it's map the device input and output through this memory map, and then you define buffer cache so that it will improve the speed. You can transmit between memory and GPU device and a CPU, in more unified way, okay. So I think in this case it's a zero copy and fast access to the data. So this is MMIO, which is memory map IO, which make use of the unified memory cache. Okay, and this is another picture of the GPU. I think it's similar to the previous one, but organization, the arrangement of the block, I mean, it put in a different perspective. Okay, I think this one you can, this is an overview of GPU where you have this memory access, memory device, and then you have MMIO, which is essentially the implementation of unified buffer cache. Okay, so that your eventually your GPU can quickly communicate to GPU, okay, in more efficient way. So I think that is the end of file management or file implementation. I have two more slides to cover with respect to when we run into issue in terms of inconsistency. I'm not sure any of you guys have encountered an issue, especially either Linux or Windows, that when you start your, let's say that when your system suddenly shut down or abruptly kind of um, crash, okay, and then when you reboot the system, sometimes it allow you to reboot, but instead of you get your windows, you are logged in, okay, but then you see a lot of things splitting on the screen, like blue screen with a lot of text, or black screen, and then you see FCSK, file checking or file system checking, okay. Those are situations where the system try to recover inconsistency of the file system, okay. The issue such as, as I told you, this is a way that the application will use the storage. So in that case, it has a various handshaking or multiple memory space that from user space to kernel space and to the actual storage, okay, all and all supposed to be the same data, but then once that file being used, okay, your application may be currently use certain block and start doing something, and then your kernel are tracking that you have not update or flush that data into all the way to the secondary storage. Let's say that if your system is crash here or crash here, so you might end up with inconsistency data, right, or inconsistency of the file system. So what do you do? So in that case, inconsistency, you have consistency checking that compare the data in directory structure and the data block on the disk and try to fix those consistency. As I told you, you have this bitmap, you have bitmap, whatever the free space bitmap. You also have, the information to the file. You also have the file table that you may cache, and as well as the system may have a the file log, or whatever the log file that tracking the all activities to the file system. Okay, also sometimes you may run into issue that some file or some certain file or file system, you may have a severe issue that it cannot recover. So in that case, backing up system, I think it's a good idea. Sometimes, you may back up system and put all your backup into the same location. But in case that you have disaster happen, for example, 9/11, 20% of the company in World Trade Center cannot continue on their business. Okay, they have to restart the whole thing because they back up their system, but then all the tape they put into the same building or the same data center there. So therefore, after 9/11, 2001, the data, this disaster recovery or the disaster preparedness has been kind of like spur or being become necessary thing or necessity, okay, that a lot of enterprise organization make sure that not only their backup but they also ensure the disaster recovery. Okay, so therefore the network storage, the disaster recovery site is quite important in order to store your important data in remote site. Hopefully that we don't have end of the world, because sometimes let's say you have an earthquake or you have a tornado, maybe one side, one location may be wiped clean, but then you still have your storage somewhere. Okay, also within file system you have a file a mechanism called journaling file system, which is the file system that trap all the change that has not commit. Let's say if you open a file and then read something, but then you have not commit or complete that operation, like write. Sometimes, your write may be write and commit, meaning that flush something into your secondary storage. Okay, say that you declare done with that operation. If it's not done, then the system will have that operation open. So therefore, during the recovery, it go and consult from various aspects, including this generating file system, which is there is a mechanism called log structure or circular logs, okay, which is a record in which represent all those file operation, okay, that has not any operation that has not commit yet. Commit operation meaning that the operation that you declare is complete, okay. So um, with that, you have log structure which record all the update of the file system as transaction. Okay, so all transaction is written into the log in case that you have to recover your file system, or when you restart the system shut down without gracefully shut down, then it's gonna go consult this log and then make sure that it will check consistency and then start doing something. Okay, so I think, as I told you, in the case of file system crash, all remaining transaction must be logged and must still be performed in order to ensure the consistency. So I think right now we have around 10 minutes left. Okay, I'm gonna stop at this point. Okay, and then you have question, type something, but then I'm gonna quickly show you a few things that may help you in terms of your textual program. Okay, um, I think last time we stopped somewhere. Show you. I think this is last time when we talk about the textual. I think I already posted this one. Okay, so I talk about some useful information and the logic in which how do you deal with your textual program. Okay, essentially beside three built-in command that previously, if you take 222 with me, cd, pwd, and exit, then you have to support set as well as list. Okay, set, list, and then the usage of those set, which is variable setting, as well as vertical bar. Some of those when you do set, meaning that when you set the new variable, okay, you can set the new variable that you can use the variable later on by define $sign something. So that does not involve with the system call. Those are more toward a user interface that you have to pass the command and understand the new command as well as the new notation. So in that case, the token that you read from the input, you may have to go multiple times to see whether you see $sign as the first character to any token, and then you would look up to see whether that is a variable that previously defined or not. So those are just programming. It does not require a whole lot of knowledge, but allow you to have more complex programs, so then you can practice more C programming experience. Because trust me, when you graduate, not only you have web-based type of job, which is PHP or something. If you start writing program, for example, you work for Google that you're supposed to do TensorFlow or TensorFlow developer, you may have to start program your application in C that communicate with GPU through CUDA. So knowing or having some other programming experience, I think it's helpful. But also another important feature to the textual is that you have not implemented in 222 is the pipe or the vertical bar. So in this case, the same thing, the first you have to scan through your input, okay? And the second pass, you need to determine whether there's a vertical bar or not. If you have vertical bar, then you will separate the substring from the left of vertical bar to be the first command, and then the right hand side to be the second command, okay? And then to create the pipe, In that case, you have to create two processes instead of you do one fork and exec. Then you're gonna do two fork and exec, and then when you do two fork and exec, then you would use a certain system call to connect standard output from the first command as standard input to the second command. So those you can use the system call called dup or dup2. Okay. Now let's take a look at. I think these are a various Linux system call that you can use. It's not limited to this, or you don't have to use them all. Whatever you think that it will appropriate use, you can use dup or pipe. I think dup and pipe would be useful in order to support the pipe command. Okay. Now I think this we talk about execs, various exec. Okay, the one that I recommend is using exec VP. You guys remember exec, right? Once you fork, create a new process. Okay, then you use exec to load the application or the program that you want to run. So in fact, for the non-built-in command, then you have to fork a new process, and then you exec the command that the user type which are non-built-in, and then pass through to the format or the syntax of execvp. And I recommend you to use execvp because execvp it has the syntax that naturally fit to your the list of tokens and the syntax that you can easily use. Okay, so this is where we stop. I'm not going to talk about execvp, but there are example code that I upload to Moodle, so you can grep execvp star c, for example. If you want to know more, then um, grep execvp star.c. Then you're gonna see the file, execvp123, I mean, those are examples that we demonstrate how to use execs. Okay, now you can see that there's also sample code called pipe.c. Pipe.c is a sample code that, assuming that you already know subcommand 1, subcommand 2, that's separated by vertical bar. So in that case, you can fork the first subcommand. First fork the process, and then execvp with the first subcommand, and then you will fork the second process, and then execvp with subcommand 2. That's separate by vertical bar. But before you fork, okay, and then exec, then you have to connect the standard output from the first process as standard input to the second process. Okay, so now let's move on and then quickly see those. Okay, so you have exec vp. We're not going to talk about those things, and these are examples that you can take a look. Okay, one thing that I want to mention for someone who has not taken class with me, okay, in this tech shell, because you use various system call, and sometimes you have no control whether the user provide the correct input or not. But then you're gonna parse and then make sure that you will handle those error based on conventional way. Okay, so in some case you cannot, let's say in case that user type exit, then you exit. Okay, but then in case that there's some issue that you detect and you cannot recover, then you can exit your shell, okay, by calling exit with certain value there. Now when you have some, we're not going to talk about weight, but I think quickly on error handling. Okay, some detail you can read from man page, but then minimum when you call any system call, you have to check the error code. Okay, which store the error code store in a special variable called error node. Okay, ERRNO. Okay, I'll show you in the next slide or sample code. Okay, and then you can use this error node to print out human readable, because the system call will store some error code, some number, which you can look up and see to get the string that map to this error code. Okay, whether system resource memory is running low or something like that. Okay, so you use this error node in order to report error code or error condition. Okay, And then when you report errors, you can either use fprintf to standard error, or you can use p errors. Okay, p error is the built-in library function that will channel or print out the error message into standard errors. Okay, if you guys remember, when we talk about standard IO, there are three channels: standard input, standard output, and standard errors. Standard output and standard error, it looks similar, like you display something to terminal, but then standard error is a special display terminal channel that you only put the error message. So in that case, you would allow the user to separate a regular message to error message. Okay, that's a way to capture that particular uh, uh, whatever standard errors or error messages. Okay, I think this example simply show how to use p error to print out could not open the file to standard error. So instead of you use fprintf standard error, you can use built-in or library function called p error to put this message into standard errors channel. Okay. Also, you can use string errors. Okay, string strerr, and then given error no. Okay, not num. In fact, the argument called error num, but then there is a system defined variable called errno that you can pass as argument to this. So in that case, it will print out or return human readable string for you. Okay, if some of you guys have to go, you can go, but I'm gonna continue on and then touch upon the pipe concept. Okay, so that some of you guys can get started or move on to the next feature in our texture program. And in this case, you guys remember, I think I mentioned about error node here. So in fact, error node is defined in this error node.h, which is a system variable that any system call when it encounter issue, it's gonna save the error number, okay, into this error node, and then you can use error node as an argument to a library function called string error that it will print out the human readable number. So in this case, I mean, you can take a look at string err.c sample code and run this one if you guys have not done. What I'm trying to tell you is that in your texture, you have to have error checking, because a lot of time you have no control. User may issue or type something wrong or some silly command. And in that case, you will handle up to some level, but also if there's some error or encounter to those error, for example, if the user try to open file that the file does not exist. So in that case, when you start performing those, then those system call, when there's some issue there, this would be mechanism in a way that you can report this error to the user. Okay. The last thing that I want to discuss here is the idea to support pipe. Okay. For example, if the user type ls-l pipe more. So in this case, you're gonna have to break, the command, the string into multiple token here. Okay, so in this case, you can have token 1, token 2, 3, and then 4, right? And here, the second pass, you have to go through again. And then when you see vertical bar, then you're going to treat this one as substring 1 and substring 2, which is command 1 and command 2. So in this case, you're going to have to create two processes that will execute this command. And second process will execute this command. But before you do so, then you will connect or connect the pipe, okay, by mapping standard output from the first command as the second, the standard input to the second command. Okay, so this is the idea. Okay, so there's a system called pipe that allow you to create unnamed pipe that provide two file descriptor, input and output, read or write. Okay, and then once you have the pipe, then you can use dup or dup2, okay, in order to create the duplication of that pipe, and then you can start connect standard output for the first one as standard input to the second process, which a file called pipe.c would demonstrate those. But also there's some issue with pipe.c I need to warn you. Okay. Now another set of system called dup and dup2, which is they perform similarly except different syntax. Okay. If you see that dup is you are duping, okay, and then it will return the duplicated file descriptor as the return value, and you can assign those to the new file descriptor, okay, or you can use dup to by dup the first old file descriptor to the new file descriptors, okay. Now um, example how to use just dup, okay. Here is called mydup.c. I'm not sure, but I have somewhere here, but I think it's just uh, it's not that difficult. We open the file, we declare three file descriptor, fd1, fd2, and fd3. Then you start open the file test.txt, okay, which you provide some option here, read, write, and then if you want to truncate, if the file has if the file exists, then you want to truncate and start from scratch, okay. So the open will return to file descriptor one. Now you print out the value of file descriptor, which is some number, doesn't matter. Now you dup from D1, okay, which is the file descriptor, the open file test.txt to FD2, and then you just print out FD2. So this is just silly example to just show how to dup and then print file descriptors, okay. In fact, I think you're gonna see some -1 or some weird number. This is just show how dup work. Now, if you take a look at dup .c, which demonstrate dup2, okay. Let me see, vi dup.c. Now dup.c is, you have file descriptor here, fd, and then you just simple printf standard out, okay, and then ft post is just a position to those file, and then f flush, okay, it's just another system library function that you want to flush. Make sure that you don't have anything in the cache, okay, or buffer cache, okay, you flush it out, okay, and then you start obtain the position of your standard out, okay, and then after that you use dup to dup the standard out to fd, okay, and then you just reopen by mapping, this standard out to this file. So whatever you print after f print, anything that from standard output is gonna be written into a file. You can remember f reopen when we discussed greater than sign or less than sign, okay. And then later on we demonstrate, we flush again standard out, and then we call dup2, and then we close fd because we already have dup2 to this standard out, okay. This is old file descriptor to new file descriptor. So in that case, after we dup, we can close it out, okay. And then we call clear error before we set the position and print out. So this is just demonstrate how dup and dup2 works, okay, which is duplicate file descriptor, and then you can start using, okay. Simply you cannot just use assignment. The dup is mean deep copy in terms of the file attribute. It's more than the number. In fact, there are some mechanism underlying. That's why you need to use dup in order to duplicate file. So now let's take a look at the pipe, and I'm gonna point out to you that there's some potential issue, okay, that you have to be aware of, but then part of this code would work, okay. Now let's ignore all this include file, okay. Now let's take a look at the main program. Now in the main program here, I declare fd an array of two file descriptor, because when we call pipe require an array of file descriptor, which is read and write, okay. The beginning of the pipe and end of the pipe, okay. So the read and write is gonna be first in and first out. You guys with me? So this is the way how to use pipe, okay. Pipe require an array of two file descriptor, okay. Now I will create a command, okay, which is command, and then we have subcommand 1 and subcommand 2. I'm simulate that. Let's say that you have your parser that read from the input a string of characters, okay, and then start tokenize, okay, in order for you to separate into two subcommand. So let's say that I'm simulate that you can have subcommand one as ls-l and subcommand two as more. All these simulation I'm gonna show how to use pipe create two processes. The first process I'm gonna run subcommand one, which is ls-l, and the second process I'm gonna run command two, which is subcommand two, which is small. And then before I do that, after I create or when before I create, then I will duplicate standard output of the first process as that second as a standard input to the second process. Okay, so in that case, I would have pipe. Okay, create pipe first here, as you see here. Okay, and then now I'm ready. Now I create the first process fork, okay, which is child process one, okay. Then I'm start, you know, remember in terms of exec vp, okay, we need to create an argument list, okay. So in that case, you know, I think we're gonna create ls-l into this argument list, okay. So essentially this is just create an argument list, but in fact if you have written program text shell that you already have is a sequence of tokens there, you already have this argument, okay. So now here in this block you already create the pipe. Now you first, because this would be subcommand 2, which is the more command. You don't need the write because you need read, right? In terms of file descriptor. Imagine that you can have the pipe that connects standard output and input, okay? And as the mechanism that you will connect process 1 and process 2. But then only the pipe here. The second command, you need only read because you want the standard output from the first command as standard input to the second command. So therefore, you don't need the write descriptor from this pipe. Okay, you want only read descriptor. So therefore, you close file descriptor 1 here. Okay, and then you do file descriptor 0. Okay, to the standard input here. Okay, and then once you do, then you close, and then now you're ready to exec the command, okay, which is command 2. Now another process, okay, which is you're gonna run subcommand 1, because in this case you don't need the read descriptor, only you need read descriptor, you don't need read descriptor to this pipe, so therefore you just close it, and then you drop, you know, the file descriptor 1, okay, to 1, meaning that the output, okay, from your standard output you're gonna map to, or this file descriptor gonna map to the standard output, okay. So now you have pipe that connect between two, and then after that you close file descriptor 1, and then you call exec. So this segment of code that from subcommand 2 and subcommand 1 will connect, and then the pipe will also create, and then it will close the one that not being used, because the pipe you need to use only standard output, okay, from the subcommand 1, and then you no longer need read on the file descriptor to this pipe, okay, from the subcommand 1 as the first process, and then for subcommand 2, which is second process, you will need a standard input, okay, which you dupe and then close appropriately, and now it's allow you to connect, okay. So once you run this program, then it will exec fork and exec subcommand 1 ls, and then the output will channel to subcommand 2 that more, and then it will process, and then it will finish. Care must be taken, guys, okay. One thing that I want to warn you, okay, when you use this pipe and set up all this, because the next command is not necessary that you're gonna do this pipe again. So therefore, once you do and then you close all these file descriptor, you need to reset it back so that it would not have side effects. So I'm gonna show you what I mean by that, okay. Now when I compile this one, gcc pipe.c, okay, and then when I run a.out here, you're gonna see that it's gonna do ls-l and pipe 2 more, okay. Now it's finished and everything fine. Now you can see that my screen count get messed up there. You know why? Because I map standard output and input. I didn't reset it back. Okay, so I'm giving you some additional information and sample code that you can continue on and add the pipe feature there. But only thing that you need to figure it out is how to reset it back, okay, so that it will come back to the normal situation and continue except the next command until the user type exit. Okay, so I think I'm gone over the time, maybe 15 minutes. I think this period. Okay, um, if you guys have any question, feel free to chat to do from the live chat or send me email. And thank you a few of you guys that last week I talked to some of you guys, multiple of you guys, multiple times. Okay, I enjoy doing that because it's two-way. I understand where are you at, what issue you are running into. So you have questions, send me email. We can use the same Zoom session and we can talk. Okay, otherwise, next time when we return back, okay, and this coming Thursday, we're gonna use Zoom and then we're gonna start off the presentation based on this sequence. Okay, you guys need to go, you guys can go, but then let me just quickly show you the order of presentation. So if you go to our Moodle website, okay, and then into the period of May 5th to 11th, you're gonna see I'm posting this face to face, but also the same link we're gonna use for the next class. Also, I also add this information in terms of term, presentation, schedule, and info. We can use this Zoom, and you click read more, then you're gonna see the list, the order of presentation. So once you click that one, okay, then you're gonna see total we have 35 students here in the class, okay, and here is order of presentation. Okay, we're gonna start off with Carrick. Okay, we're gonna talk about voice OS, and then followed by Collins. Okay, gonna box game box OS, and then we have David. Okay, on Docker. By the way, the person that I have gray and then have no submission, I have not seen your submission on Moodle. Okay, so please quickly submit your stuff there. Okay, and then after there is Matt, Tim, Steve. Don't worry about this. The title. This title. I think some of them are the original title that you give it to me, and maybe sometimes it may be mismatched. But the order, I think, there would not be change. Okay. Also, I think Jamon, please contact me. I think I skimmed through some of your presentation. Most of you guys, I think they're fine. Um, some of them are good. Some of them I think need to be improved. So I think if you want to use the new version that you have more effective presentation, please do so. Jamon, contact me because I look into your topic. I have some question. I already send you email. Okay, and for 3 or 4 people I have not received your topic or your presentation file yet. Okay, so do as soon as you can. All right. So I think that's it for today. Next class we're gonna use Zoom session. I'm really looking forward to start hearing your presentation. Okay, which I'm hope to ask some question in live, and then I will record those sessions and post on Moodle. As I told you, okay, here the presentation will constitute of 50% of your score here. So if you miss your presentation, that means you drop immediately half grade there. Okay, I believe the presentation is 10 or 15 point, so therefore I think it's going to constitute at least half or 1 grade. Okay, so so please be sure that you log in on time. Otherwise, please stay safe, and I'll see you this coming Thursday. All right, guys. Have a good day. Bye now.